Alright, in this video we're going to look at some linear inequalities, and near the end we'll look at two examples of a polynomial inequality, and then also two examples of a rational inequality and what we need to do for those. So let's go ahead and go over some of the basics here. So you have your first symbol there, that's the less than. We use an open circle and parentheses with less than. Same goes with greater than. You use open circle and parentheses. When we get into the less than or equal to and the greater than or equal to, you'll use closed dots and then also brackets if you're doing any sort of interval or maybe the graph. And then one thing to be careful, no brackets at plus and minus infinity. The brackets means we include the number. Infinity is not really a number, it's an idea. Sometimes it's treated as a number, but for us we're going to treat it as an idea, and that means that we go indefinitely to the positive infinity and negative infinity. So it is not treated as a number, so no brackets at infinity. Okay, so let's go ahead and get going, look at some examples here. So first we're going to start off with real basic things and do both the graph and the interval, so real basic inequalities. So here we have x in the heart, or x less than 3. So in words that is x less than 3. We'll draw our number line, put in your minus infinity and infinity. And probably you've always been, trained to do 0 and then 1 and then 2. So we're not going to clutter this up with all those other numbers. You can if you want to, but I'm only going to put 3 in because that's the only number we're concerned with. And x is less than 3, and smaller numbers are going to be to the left there. Smaller to the left, larger to the right. So x is less than 3. Okay, sometimes they use a closed dot instead of the parentheses, which I have going on, or not. It would not be a closed parenthesis. Sorry, it would be an open circle there. But I think in the Lumen and the MyOpenMath, they're probably going to use the parentheses. Okay, so we've already shaded where we need to go, and that is from minus infinity all the way to 3, and that's your interval, and then you got your graph also. Okay. Let's look at what's called a compound inequality, and that's where we have more than one inequality. So we have negative 3 less than or equal to x less than 5. And these aren't too bad to graph because x is trapped between minus 3 and 5, so that's where your interval is going to be. Okay, so in words, this is 3 is less than or equal to x and x is less than 5. So minus infinity, infinity on your number line, we're interested in two numbers, minus 3 and 5. Bracket at minus 3 because of the less than or equal to, and then strict inequality because of the x less than 5. And we're going to shade right between them, and so your interval will be negative 3 to 5, bracket at the negative 3, and parentheses at the 5. Third example is also going to be a compound inequality, but it's going to have or in between. So we have x is less than or equal to 2, or x is greater than 5. In words, x is less than or equal to 2, or x is greater than 5. We'll go ahead and put that on our number line, minus infinity, infinity, 2 and 5. X is less than or equal to 2. We're going to go to the left because that's less than. And then x is greater than 5. Larger is to the right, so shade to the right. So minus infinity to 2 with a bracket, and then we have to jump. And so for the jump there from one interval to the next, we'll use the union or the horseshoe. In the MyOpenMath, I think you just use the upper MyOpenMath, or the Lumen, you use the uppercase U, I think, for the union. So minus infinity to 2 with a bracket, and then 5 to infinity and beyond. Okay, so that's the real basics. We're going to look at some solving linear inequalities, a couple examples of those. That's going to be very similar to solving linear equations, and then we'll get into the polynomial and rational inequalities. Okay. All right, so let's fast forward through me writing all that down. Okay. So the goal with solving a linear inequality is the same as solving a linear equation. You're going to isolate the variable. The one catch is if we multiply or divide by a negative, we need to flip the inequality. Then you'll write your solution as an interval. So for example, 2 is less than 5 is a true statement if I divide both sides by -1, -2, and then -5. How do they compare? Well, you can think of larger numbers to the right. So here's 2 and here's 5. So 2 is greater than 5. Here's -5 and here's -2. So which is larger out of the two of those? That's going to be -2. So we need to flip our inequality. So -2 is greater than -5. So that's going to be the case whenever we multiply or divide by a negative. Only multiplying or dividing by a negative is when we need to flip those inequality signs. Okay. All right. So we got -2x plus 5 is greater than or equal to 25. Subtract 5 from both sides. -2x is greater than or equal to 20. We'll go ahead and divide both sides by -2. Okay, so x and then -10, and because we divided by a negative, we need to flip the inequality. But we probably don't want to flip it that way, and probably not that way, so I'm just being silly. Alright, so there we go. X is less than or equal to -10 is how that's supposed to be flipped, okay? We'll go ahead and draw a really abbreviated number line, -infinity to infinity, throw in -10, and then we will go -infinity to -10 with a bracket there as our solution to this particular inequality. And we certainly can have fractions too, so 1/2 x minus 3 less than or equal to 3/2. We'll go ahead and identify what the common denominator is, or the least common denominator. Both denominators we see are 2, so that's our LCD. So we're going to multiply everything by 2, or 2 over 1 if you're a fraction. So 2 over 1, 2 and 2 over 1. 2 over 1 times 1/2 x minus 2 times 3 less than or equal to 2 over 1 times 3/2. Okay, so that's just multiplying everything in the inequality by 2. 2 is positive, so we don't need to flip the inequality. So we have x minus 6 less than or equal to 3. Add 6 to both sides. And we have x is less than or equal to 9. Draw your number line. And write your interval. Okay. All right. We'll look at a couple more examples. I think we got 4 more of these. So 17x plus 12 greater than or equal to -4 plus 9x. Pick a side, any side, to get all the x's on one side. So subtract 9x and subtract 12. Subtract 12, subtract 9x. 8x is greater than or equal to -16. Divide both sides by 8. 8 is positive, so we do not need to flip the inequality. X is greater than or equal to -2. Do your number line, and we get -2 with a bracket to infinity. Okay. The next 3 are going to be compound inequalities. So a compound inequality is going to have 3 sides. So with standard inequalities, or inequality with one inequality in it, or equations, you have 2 sides. So anything you do to one side, you do to the other. Well, if it's a compound inequality, then anything you do to one side, you're going to do to all 3 sides. So these are going to be rigged with some sort of expression with x in the middle, and our goal is to isolate that in the middle there. And so to get rid of that -3, we're going to add 3 to all 3 sides, and we'll have -12 less than or equal to 4x less than 4. To get rid of that multiply by 4, we'll divide all 3 sides by 4. So divide by 4, divide by 4, and divide by 4. -3 less than or equal to x less than 1. And we do our number line. We're going to go from -3 with a bracket to 1 with a parentheses. -3 with a bracket and 1 with parentheses. Okay, so that wasn't so bad. Let's go ahead and take a look at another one, maybe one where we end up dividing by a negative and see how that affects stuff. Okay, so 6 less than or equal to minus 4x plus 6 less than 14. So we're going to isolate that x there. So the first thing we're going to do is we're going to subtract 6 from all three sides. 0 less than or equal to minus 4x less than 8. And then we're going to divide all three sides by negative 4. Divide by negative 4 and divide by negative 4. Okay? Okay, and there's our two inequalities flipped. And we get 0, x, and minus 2. Okay, so x is going to be between 0 and negative 2, but let's go ahead and write it in from smallest to largest. So negative 2 less than or equal less than x less than or equal to 0. So we just make sure that those alligators are still eating the correct numbers there. So between x and negative 2, the x is eating the the alligator is eating the x there. Okay. Alright, so we got the x wedged between negative 2 and 0. So we'll go ahead and do our number line. Parentheses at negative 2 and a bracket at 0. Okay. And yes, of course, we can have fractions in compound inequalities. So negative 11 over 8 less than or equal to 4x plus 1 all over 9, and then less than 25 over 8. We'll identify our least common denominator between 9 and 8, and that's going to be 72. So we're going to multiply all three sides by 72 over 1, because everything's a fraction. That's going to be a little bit easier. 72 is positive, so we do not need to flip any inequalities. So 72 over 1 times negative 11 over 8 less than or equal to 72 over 1 times the quantity 4x plus 1 over 9 less than 72 over 1 times 25 over 8. And then we'll do some canceling here. 8 goes into 72 9 times. 9 times negative 11 is negative 99, less than or equal to. 9 goes into 72 8 times. 8 times 4 is 32. So 32x. 8 times 1 is 8. Less than. 8 goes into 72 9 times. 9 quarters is $2.25. Okay. Now we've eliminated the fraction. So now we would like to isolate the variables. We're going to divide. I'm sorry, we're not going to divide yet. We could. You could absolutely divide now, but let's not. Let's subtract 8 first, and then we'll divide. So subtract 8 from all three sides. Negative 108 less than or equal to 32x, and less than 217. Now divide by 32. Again, we're dividing by positive numbers, so we don't need to flip the inequality. 32 and 108, I think, are both divisible by 4. So we'll divide by 4, divide by 4, and we get 27 over 8. Oh, we lost our minus sign. Let's go ahead and sneak that minus sign in there. So negative 27 over 8. Well, I'm going to try to. There we go. There's our minus sign. Negative 27 over 8, less than or equal to x, and less than 217 over 32. 32 is 2 to the 5th, and 217 is an odd, so there's nothing in common. Okay, negative infinity to infinity. And we have negative 27 over 8 to 217 over 32. Over 32. Bracket at the negative 27 over 8, parentheses at 217 over 32. Okay, so negative 27 over 8 to 217 over, let's go back, over 32, sorry guys. Over 32. Sometimes I get carried away in the excitement and we'll write down the wrong numbers, but we're good now. Okay, so the next section we're going to look at, I think I also have another video specifically on polynomial and rational inequalities. Certainly that'd be something good to look at for on Khan Academy, Khan Academy, if I can talk here. Alright, so here are your guidelines for polynomial and rational inequalities. First thing you would like to do is make one side of the inequality 0. Then you'll factor the numerator and the denominator. Sometimes you won't have a denominator. locate all boundary points, and essentially what a boundary point is going to be for us is going to be an x-intercept or a vertical asymptote. Vertical asymptotes we won't really cover until unit 2 or 3, so it's coming up in a little while. So what that basically does is we're solving the top and the bottom of a fraction equal to 0. The next thing we'll do is we'll make a sign chart around your boundary points, and you're going to test in each interval. The solution is the union of all true intervals. Okay, so we're going to work through a couple examples and show you what that looks like. Okay. All right, so number 10, we have x squared minus 9x plus 20 less than or equal to 0. That factors into x minus 4 and x minus 5. So your boundary points are x equals 4 and x equals 5. So if we were to solve that, you'd take each factor and solve that equal to 0. Okay, so that's how we're finding those. Okay, and so those are my 2 boundary points. We're going to draw our number line. So you got minus infinity to infinity, 4 and 5. I like to put the boundary points on the bottom, and then I like to put my test points above the number line and circle them, and that kind of helps me organize things because sometimes it's easy to confuse your boundary points and then your test points. Okay, so we need to test a number between negative infinity and 4. So 0 works, 4.5 works between 4 and 5, and after 5, 6 works. Okay. Now, it doesn't matter what number you choose, you just need to make sure you choose a number that's in each interval. 4 and 5 is the only place where this polynomial is going to change signs, so that's all we need to test around. So if you wanted to test 1, you could have in the first interval. If you wanted to test 4.000000001 in the second interval, that'd be fine. If you wanted to test 1,000,000 in the third interval, that'd work. You'd still get the same conclusion. We're looking at, is it positive or negative? This particular one, we have x squared minus 9x plus 20 is less than or equal to 0, so that's going to tell us we want negative. Okay, alright, so we'll test 0, and we'll just throw it in the, I like to use the factored form of the inequality because it's a little easier to do the computations. You can use the original if you want. Okay, so 0 minus 4 times 0 minus 5, is that less than or equal to 0? So multiplying that out, 20 is less than or equal to 0. That is false, and so we throw away that section. Okay, now we'll try 4.5, and so we have 4.5 minus 4, and 4.5 minus 5, less than or equal to 0. Multiply that out, that would be negative 0.25, less than or equal to 0. That is true, and so we'll include that middle interval. And finally, we'll choose and test 6. So 6 minus 4, 6 minus 5. Is that less than or equal to 0? Well, that's going to be 2 less than or equal to 0. I think that's false, so we will throw that one out. So we're going to be doing 4.5 to 5. I'm sorry. See, look, I just confused my my test point with my boundary point. We're going 4 to 5 because that's what we got here. 4 to 5, that's where it's true. Because it's a less than or equal to, we're going to use brackets on both of those. Okay, so 4 to 5. All right, so we're going to look at one more polynomial inequality, and then we'll look at 2 examples of rational inequalities. So here we have negative v to the third power, less than or equal to v squared, minus 132v. The first step is to make one side of the inequality 0. So I'm going to go ahead and add v cubed to both sides. So add v cubed to both sides, and we'll see about factoring it. So v cubed plus v squared minus 132v. Everybody's got a v in common, so we'll go ahead and factor a v out. So v and then v squared plus v minus 132. 12 times 11 is 132. So if we did like a positive 12 and a negative 11, when we add those, that'll give us 1. So that's our winning combination there. So we want to do 12 and minus 11 for the factoring there. So you got v and then v minus 11 and then v plus 12. Okay. To find our boundary points, that'll be v equals 0, v minus 11 equals 0, and v plus 12 equals 0. So we'll get v equals 11 and v equals negative 12, in addition to v equals 0. Okay, so those are going to be our boundary points, and then we'll have to test around those. So let's get our number line going here. So boundary points are 0, 11, and negative 12. Negative infinity, infinity, negative 12, 0, and 11. I'm not real creative with my test points, so I'm going to choose something close to negative 12 on the left, negative 13, negative 1, 1, and 12 all will be in those appropriate intervals. And then it's just a matter of plugging it into really any of these forms would be fine, and you're just looking for, is it a true statement or a false statement. I'm going to go ahead and use the factored form because I find that to be the easiest to kind of work with. Okay, so we're going to plug in minus 13 into the inequality, replacing the v's, and then working that out. So some computation. Okay, so finally we get 0 is less than or equal to negative 312. That is false. Cross that one out. Testing negative 1. Go ahead and plug it in for the v's. So 0 less than or equal to 132. That is true, so we're going to include that interval. Here we go, testing 1. 0 less than or equal to 130. That is false. So throw out that interval. And finally 12. We're going to test 12. So plug in 12 for the v's. So mostly just a tedious here. So 0 is less than or equal to 288. And that is true. Okay. So a little bit tedious with the computations, but we got two intervals from minus 12 to 0 and then from 11 to infinity. We had a less than or equal to in the original inequality, so we're going to be using brackets with the exception of infinity. So we're going to do minus 12 to 0 with brackets, union 11 bracket to infinity with a parentheses. Okay, so that is polynomial inequalities. The next thing we're going to do is we're going to look at the rational inequalities. They're real similar. So let's say we have x minus 4 over x plus 2, and that is greater than or equal to 0. So our first step is to make one side of the inequality 0. We have that. Both the numerator and the denominator are factored. Finding your boundary points is solving the top equals to 0. That's going to give us x equals 4. That's what's called an x-intercept. And then x plus 2 equals 0. That's going to give us x equals minus 2. Later on, that will be a vertical asymptote. And those are my two boundary points. So I get them by solving the top and the bottom equal to 0. Now, the negative 2 is in the bottom. That makes the bottom 0. That's going to be a restriction, so we won't put a bracket at negative 2. It's a restriction. All right, so boundary points are x equals 4 and negative 2. X equals negative 2 is a restriction. That if we plug it in, we divide by 0, and thou shall not divide by 0. And so it doesn't get a bracket. It'll just get a parentheses. Okay. So same game. Draw your number line. Plug in your negative 4. Where did negative 4 come from? I don't know. Sorry. Plug in your negative 2 and your 4. So that's what you're going to test around. Okay. And then I've drawn in like a dash line here to kind of simulate the vertical asymptote. Okay. So we're going to test negative 3. Probably 0 and 5, and we're just going to plug them into the inequality and see if it's true or false. Okay, so plugging in at negative 3. Okay, so that's going to be 7. 7 greater than or equal to 0 is true. Plug in 0. Okay, and minus 2 greater than or equal to 0, that is false. So we will throw that interval out and then plug in 5. And we'll get 1/7, and 1/7 is greater than or equal to 0, so that is true. So we'll accept the last interval. Okay. So our true intervals are minus infinity to minus 2 and 4 to infinity. And normally we'd do a bracket at the -2 and the 4, but because -2 is a restriction, it's going to have a parentheses. So negative infinity to -2 with parentheses, the union 4 to infinity, and the 4 gets a bracket. So again, -2 is a restriction. We can't plug -2 in. When we put the bracket, that means we accept that number. That number is included. We can't include -2. It causes us problems. Okay, we'll look at one more rational. So we're going to look at x minus 9, x plus 9, all over x, and that's less than or equal to 0. Define your boundary points, set your factors, equal to 0. So we're going to have 9, -9, and 0 as our factors. And so we're going to test around those in the inequality, and we want where it's true. Boundary points, 9, and -9, and 0. X equals 0 is a restriction because we can't divide by 0, so it will not get a bracket. So no bracket at 0. Draw your number line, put in -9, 0, and 9, and then we need some test points. So maybe -10, -1, 1, and 10, and we'll plug them into the inequality. So plugging in -10, and then we're looking for, is it a true or a false statement? So nothing too crazy, just tedious computations. So we get 100. What do we get? We get 19 over -10. That's going to be negative. Negative is less than 0, so that's true. So we'll take the first interval. We'll try a -1. So plug -1 in. And let's see what we get. We get -80 over -1. Is that less than or equal to 0? So is 80 less than or equal to 0? I don't think so. That's going to be false. So I'm going to throw that interval out. Okay, then we'll try 1. 1 minus 9, 1 plus 9, all over 1, less than or equal to 0. Is that true? Is -80 less than or equal to 0? I think so. That's true. So we're going to include that interval. And finally, we'll test 10. 10 minus 9, 10 plus 9, all over 10. Is that less than or equal to 0? 19 over 10, is that less than or equal to 0? Nope, that's false. So we throw that interval out. Okay? So our true intervals are -infinity to -9, and then 0 to 9. We will have a bracket at -9 and also a bracket at 9 because they're included, and we have the we got that less than or equal to sign there. However, at 0, that is a restriction, so we cannot include it, so we use a parentheses at 0. So we're going -infinity to -9, parentheses at infinity, bracket at -9, union, parentheses at 0, and bracket at 9. Okay? And that is our polynomial and our rational inequalities, along with some linear inequalities and a little bit of review of inequalities there. Okay. So that is it.